In the last lesson, we organized only a few files. With many files, it's useful to use pattern matching or wildcards in order to help specify files with less typing. I've created a directory, and using a touch command and mkdir commands, I've created a number of files and a few directories, of which there are patterns to a number of these files. When I do an ls, I see all of these files. If I do an ls data, that's the directory. If I add the a, I get no such file or directory. If I hit tab twice in order to see what the choices are, then I see that there are a number of data A files. Using file name wildcard characters, the way that I would view all of these is to add the asterisk. This is similar to other command line environments as well, where I specify an asterisk to mean 0 or more characters that match with this. In this case, I did data A asterisk, so I got everything that started with data A. If I just do data asterisk, I will get the contents of the data directory down here at the bottom, in addition to all of the data files that have something else on their name. I can use the asterisk in the middle as well. It doesn't have to be at the beginning or the end. For instance, at the end, I could say, give me an ls of everything that ends in old. And I get all of the files that have the .old extension. But if I use an ls of data asterisk 3 asterisk, that's also valid. Finds all of the files that have a 3, that start with data, have a 3 in them, and it doesn't matter what is between the data and the 3 or what is after the 3. Again, looking at all of the files in the directory, we can begin to see how that pulled out that particular pattern. So with this, I can begin to do my organization in a little bit easier fashion. For instance, that data directory has nothing in it yet, but I could make a directory in data of A files, and then I could move the data A asterisk files to the data A files directory. Now all of the data A files are no longer in the current directory, but they are in the data A files directory. I've moved them using the asterisk for pattern matching. The asterisk is the most common of the pattern matching characters, but it's not the only one that's used. Let's take a look at the match files that I have here. If I try to look at match asterisk, I see all of the combinations. I have a match 1, match 11, match 1A. If I do an ls of match question mark, all I get is match 1 and match 2. The question mark is another wildcard used with file name generation. It matches a single character. There must be a character. So for example, if I touch match, if I do an ls of match question mark, I won't find match because there has to be some character. But I also am not finding match 11 because there can only be a single character. I can use the question mark in multiple places as well. Match question question, and I find the match 1A as well as match 11, match 1B, match 22, anything that has 2 characters after match. Remember that doing an ls of match asterisk shows me all of them, 0 or more characters, including match with nothing else after it at all. The asterisk is 0 or more of anything. The question mark is a single character, but it's any character. So the third option in the file name generation characters and wildcards is the square brackets. I can do an ls of match, and I want to have a 1 or a 2. So I have match 1 and match 2. If I put an asterisk after that, I get match 1, match 11, match 1, 2, 3, 1A. If I do match 1, 2, I do a match 1 and then look for an A or a B, as opposed to a match 1 asterisk, I get only the cases where the next character is an A or a B. And again, I'm only getting a single number on this. So match 1, 2 in square brackets found match 1 and match 2, but not match 11 or match 22. If I put a question mark, then I can have anything after that set. If I put a second set of brackets of 1, 2, I can match 11 and match 22. And it can be any combination of a 1 or a 2 in the first field and a 1 and a 2 in the second. Here I've specified just specific characters inside of my set. I can also do ranges. So I can do an ls of match and say 0 to 9. So it can be any number. Let me touch match 8, and you'll see that it also matches within all of this. I can do ranges of letters, and there's even something called POSIX character sets so that I could match white space or uppercase or lowercase. White space is not commonly used in file names, but it would be something that could be matched. The next thing that I might want to do is negate that match. So let's go back to looking at the match files and find everything that matches with match but does not have a 1 or a 2. I simply add a caret at the beginning of my set. If I put the caret anyplace else, then it'll have a different meaning. But if it's the first thing inside of the square brackets, it means I want to negate this set. I want to match anything where there is a character. And again, notice that I'm matching a character, some character, just not a 1 or a 2. So I don't match up with plain old match because there's nothing there at all. I also would not match up with a match A because, or I would match up with a match A because it's not a 1 or a 2, whereas I would not hit that if I was looking for the positive of being a 1 or a 2. So any character that is not within my set. And this can also be a range, 0 to 9, for example, for numbers, finds only match A. So 0 or more characters with the asterisk, a single character with the question mark, square brackets form a single character from a set, and the caret will negate that set. Those are what we call file name generation wildcard characters. But there are also some other special shell characters that can help with creating the files. For example, when I created all of these files, I used a touch command with squiggly braces. So I could touch a new file of old, there should be a dot, and then old, comma, new, comma, current. I do an ls of new file, and I find those three. So the squiggly braces will expand out everything that's in there separated by commas. That's what I used in order to create all of these files. It can also be used with an ls. Give me all of the files that are data that end in either old or current. I can't do that with just a O asterisk because I'd get old and orig, or ending in D, or I might be able to get away in this directory with ending in D or T, but it can be useful to generate this list with the squiggly braces to expand out when I'm looking for a string to match. One last character that can be useful is the tilde character. This represents your home directory. So with a cd command always takes me to my home directory. If I cd to a different directory and I cd to tilde, that will also always take me to my home directory. This means that I could do things in this lesson directory here, and I could try to copy the samples directory to tilde to my home directory. And now when I do an ls of tilde, I see samples is located there. So it can be a destination for my copy command. Dot being a current directory, I could have cd'd to my home directory, and then I could have done a copy -r data originals to dot the current directory. Only it's not in that location, so let's try lesson 4 originals to dot my current directory, and I can find the source and the destination is dot my current directory. So my destination could be tilde to represent my home directory. I could also try to copy originals here to another user. So if I say tilde visitor, I'm saying that I want to copy this to the username visitor, whatever their home directory is, which I may or may not have permission to do, but if I do have permission, it would be successful. Tilde by itself refers to my home directory, whereas tilde in a username refers to a specific user's home directory. And again, I can say ls tilde to list my home directory. I could say ls tilde / lesson 4 in order to view the contents of my home directory / lesson 4 as a hierarchy as well.